What are joins in SQL? This is a very basic question and my funda is always to start from the basics only. So see, here we have two tables, table A and table B. Okay. Now suppose we want to get a result set with student ID, name and department column all together. For that we will use join. We will join these two tables like this and finally we will get the desired result like this. So the definition is a join clause is used to combine rows from two or more tables based on the related column between them. Now here is the example, student ID was here in this example student ID was the related column. Now you are ready with the basics. Let's go to next question. What are the types of joins in SQL Server? This is a very important question and almost asked in all interviews for basic interviews. Okay, so first of all, outer join, we have three types of outer join. First one is left outer join. A left join returns all the rows from the left table and along with the matching rows from the right table. See in the diagram here, all the rows from the left table A will be there, right? But yes, the columns you can choose from both and A and B table. You can list this in the select column names list. Okay. Next is right join. A right join returns all the rows from the right table along with any matching rows from the left table, just opposite to the left outer join only. The third one is full outer join. A full outer join returns all the rows from both the left and right tables in the join. That's it. Then these are the three types of outer join. Now the most important and the most used one is, yes, it is inner join. An inner join returns only the common rows from both the tables and that meet the join condition. You can also see this query for this inner join and all these joins. It is pretty simple and straightforward. Based on your requirement, what kind of result, the final result you want, you can use the types of join in your queries. What is self join? The definition is very simple. A self join is a join of a table to itself. But this use of self join is slightly confusing, which I will explain now. Normally we join two tables, right? But in self join, we join one table to itself only. The main thing is, what is the purpose of this? Why we are joining the table to itself? Now let's see what does it mean and when to use it. Suppose you have an employee table like this. Here all the employees with their employee ID are present, right? Managers are also employees, so they are also present in this table with their employee ID also, right? Now most of the employee will have a manager, right? Therefore in the same table there is a manager ID column. Now listen carefully. In this manager ID column we will put the employee ID of the manager of that employee. Getting my point? For example, my name is Happy and my employee ID is 100 and my manager name is John and his employee ID is 200. So both these records are present in this table, and in my record where the employee ID is 100, corresponding to that the manager ID will be 200, who is John, who is my manager, right? So there are no separate tables for managers, all is in the same table employees. Now suppose your task is to write a query to get all the employees name with their manager's name. For example, you want Happy, my name, and my manager John. So Happy and John, you want these two names for so for that we will use what? Yes, self join. So suppose this is the output you need, employee name with manager names, so this will be solved. This will be the query we will use, and see here we are left joining employees table with the employees table only, and this is possible with the help of using this different aliases E and M, and the condition will be like m.employee ID equal to e.manager ID, because yes, manager ID is the column we have, right? And order by manager is just optional. Now this result we will get all employees with their manager names. You might say there is no manager name column here, then how you get it? Basically, while self joining, we will consider the first table as the employee, which is basically E, and the second table we will consider it as managers table. It is employee with M alias, which is like it will be considered as managers table, because managers are also there present in the employees table, right? So It is like this, and above this m dot first name means the manager first name. And I think now you know the use case of self join, right? In short, sometimes we do not have multiple tables, and at that time we have to join the one table with itself only to get the desired results. That is self join. What are indexes in SQL Server? As always, let's start with the example. Now, suppose you have a table T1 with huge data, okay, huge. Now, if you will write a search select query with the where condition in this table, then the result will be very slow, right? Like, because now suppose if you have to index on this one primary key column and store it in separate place like this, then it is easy to search in this one column, right? And that is the benefit of indexing. The first point you have to remember is SQL indexes are used in relational databases to retrieve data very fast, or we can say to improve the performance of the queries. Now they are very similar to the indexes at the start of the books, okay, which purpose is to find a topic quickly. See, we have indexes in book, then how easy it is for us to search the topic, right? Otherwise it will be very difficult. This is the brief idea about the indexes. What is clustered index? Let me give you an example first. See, this is a dictionary. Here B is the index, and below that we have all the data of related to B here, right? So basically B, which is the index, is physically stored along with the data only, right? Similarly, a clustered index is an index which defines the physical order in which table records are stored in the database. Also in dictionary you can have items in alphabetic order, right? No other way. So only one index is possible in the dictionary, right? One way, right? Similarly, table data can be stored in only one way. Therefore, there can be only one clustered index per table is possible. Now, next point is in SQL Server, if you set a primary key on a column, then it will automatically create the clustered index and on that particular column, right? So this is like the high level, or say the brief details about the clustered index. What is non-clustered index? Again, let's see the example first. See, this is a book index which is at the starting of the book, right? But it is not present along with the data, the content. This book index is stored separately from the data, not like the dictionary where the index was also present along with the data. Similarly, a non-clustered index is stored at one place and table data is stored in another place. So this non-clustered index is not physically stored with the data. Like in the case of clustered index, it was physically stored with the data, right? Another important point is a table can have multiple non-clustered index in a table. Like in a book, you can have multiple type of indexes, right? Some books can have this alphabets wise indexes like this also, which mostly are there at the end of the book, right? End of the book you can find multiple indexes, right? Here also page numbers are mapped. This is the brief idea about the non-clustered index. What is the difference between clustered and non-clustered indexes? This is the main question asked in the interviews, but I already explained clustered and non-clustered index separately, so this is going to be very easy for you. Let's quickly see the differences. First is, a clustered index is a type of index that determines the physical order of the data in the table. It is a bit similar to dictionary, which index is physically stored with the data itself. Then a non-clustered index is stored at one place and the table of the data is stored in another place. Bit similar to the like book indexes, which are stored separately from the data or the content of the book, right? Second difference is, a table can have only one clustered index, but a table can have multiple non-clustered index. Then the third difference is, clustered index is faster. Like in dictionary, the search is so fast, right? Directly go to the alphabet from which the word is started, so fast. But non-clustered index is slightly slower. Like in a book index, you have to open the index first, then you have to find the topic page number, and then you will go to the actual page number. It is good, but yes, it is slow as comparison to the dictionary or the clustered index. Now remember one thing, while creating multiple non-cluster index for in a table, do not create it for multiple columns. Like create it, but wherever it is required. Otherwise, non-clustered index is stored separately, right? And if you will create multiple non-clustered index, then they are also taking some memory, some space. So and if it is not required, then it's not good. That are the differences between clustered and non-clustered indexes. How to create clustered and non-clustered index in a table? Yes, you can create clustered index on a table like this. Create clustered index, index name, and on table name and then in bracket you can write the column names. And then this is the query to create the non-clustered index. Create non-clustered index, same like the clustered index, only index name on table name, and then in bracket you can write the column names. Now normally when you create a primary key constraint, a clustered index on the column is automatically created, right? But if you do not want a primary key in your table, or if you want, like, you drop the clustered index from the primary key, and then you can also create a new clustered index with some new column. So this is the way, this is the query you can create the clustered index in this, right? It's short and simple. In which column you will apply the indexing to optimize the query? Select id comma class from student where name equal to happy. So this is the query and you have to improve the performance. So this is a tricky question, and if you have ever created any index, then you know it, but if not, then also not a problem. Then now you will know it. Okay, so this is the query we have. Normally by default clustered index is on primary key column. So here we are talking about the creating the one non-clustered index. Okay, because we do not create clustered index, it's by default on primary key. Now the answer is we should create non-clustered index on the columns which are after the where condition, and in this case this name is after the where condition. Do not create index before the, like, for the select columns. These columns do not create for them, because your query execution, the time taken by your query execution, whether it will be fast or slow, it is dependent on this where condition column, not the select columns. Okay, now you know for what column you will create non-cluster index in your table. The columns which are frequently used in the where conditions, right?